on programming project 1. The first thing, a small feature, some of you probably already did it, but here, let me talk about it a little more. So last time, remember, we store the data in 2 list structures. So here we have our project 1 sample A, project 1 sample B. I post these 2 examples. Today, we will do project sample C. 1 sample C today, okay? So in this one, I just do a Java Bean part. It's simple, but I'd like to show you a little bit. Java Bean way to store data. All right. We have 2 list structures. The first one is a list of string object. That's for our cities. The second one is list of double for rates, tax rates. Okay, Think about, in this project, I like to practice Java Bean carrying the data. Now, although very simple, but I like you have a little experience here. So now, when we send the data to the front end for presentation, 2 drop-down lists, we use 1 Java Bean. So we put these 2 objects in that 1 Java Bean to send. Think about if we have multiple objects. So 1, 2, 3, 4, 5. So we can put all those objects as the properties of a Java Bean and send to the front end. Okay, just 1 Java Bean object, we send it. So we can create a Java Bean with 2 properties. Okay, 1 for cities, 1 for tax rates, 2 properties. Okay, setters, getters. All right, So then in our preparation circuit, after we generate these 2 list objects, we call setters to store the values for those 2 properties. Then after that, we just store that 1 Java Bean into the request scope as before. All right, Then in the request scope, we will change from that 2 list objects to 1 Java Bean object. Okay, small change. But when we retrieve data, okay, So we get Java Bean, get the first, and then there its properties. It's 2 properties. using EL expressions. How about that? EL expressions. Okay. Yeah. Just as a small practice, small experience for you. Okay, you need to go through these things to get some experience. Okay. All right. Later, I will modify project 1 sample B by adding this part. Okay, yeah. So modify the code, adding this part. So we complete project 1 sample C. Then I can post the code, source code. All right, so that's the first thing I like to talk today. Yeah. Second, still, we move to the prime factorization. Again, here I find the algorithm online from web. So this is a simple algorithm. Okay, I found it from web. So when you pass an integer, we need to modify it. We cannot use this directly because we need to use big integer Java class. So later I will talk about big integer Java class. So we do conversion. Yeah. All right. So the algorithm, because we need to write each power, we need to write based on our requirement. Each power, we need to write this format, parenthesis base, then exponent number, right? Yeah. Yeah. So that is for one power factor. Okay. Yeah. Then we need to get all the power factors putting together. That's the factorization format. All right. Here you can see when we start, first, I equals 2, because 2 is the smallest prime, right? Smallest prime. And it is the only even prime. Only even prime, 2. All the other primes are odd numbers. Yeah, so it is special. Yeah. So the first time this algorithm extracts power of 2 factor first. Okay, the first time. After that, so here you can see this while loop. That's the to get a, keep doing integer divisions. Keep doing integer divisions to extract all the 2 factor out and accumulate all the 2 factors to get a power of 2 factor. Okay, all right. And after that, so the print part, so that's the display format. And we change the format. We need to change. So this is the display format. Okay, yeah. We need to change it. Okay, our format is that way. Okay, all right. But after 2 power of 2 factor extraction, -1. So this I is reduced from 2 to 1. Why from 2 to 1? Because after 2, every time we increase I by 2, then later we change I to 1. So next time add 2 to 1, we get 3, 5, 7, 9, and so on. Okay, so we try integer divisions by odd numbers because we do not need to consider even numbers. After 2, we know all the multiple of 2 numbers cannot be prime, so we skip all the even numbers. So here the purpose is skip all the even numbers after 2. Okay, yeah. Only consider odd numbers. Yeah. Up to the largest odd number you like to have, the upper bound, square root of the given integer. Square root. Yeah. Why square root? Because we know square root of n times square root of n times square root of n equals the original number. Yeah. If an integer has a factor, non-trivial factor, if an integer has a non-trivial factor, it must have a factor less than or equal to its square root. Because one factor, you must have the other one, right? So after division, 1 must be less than or smaller than the square root. That's the reason if we just do division on all possible odd numbers here, less than or equal to the square root number, we won't miss any factor. Think about that. We won't miss any factor. Okay? Yeah. All right. But the last one we need to consider after we extract all the possible power factors, the last one, there is a possibility that that number after division still could be included in our last component. Yeah. So try to understand. Yeah. You can try your best to understand and implement. At my side, I also implement my version. Okay. Yeah. My version. If you cannot do it, I hope you can do it. If you cannot do it, I will, after I test it and fix the problem, I can post my example. So in case you cannot get it, so you try your best. In case you cannot get it, you can use my example for this part. Right now, I did it a little bit. I did a conversion part, but when I do testing, I notice some bugs. Yeah. Some problems I notice not quite right. I need to fix it. I need to test some special numbers and fix the problem. Yeah. So my current version still not ready yet. Yeah, a lot of bugs. Okay. Yeah. All right. Next, I'd like to talk about the big integer a little bit. Yeah. Because all our operations must be implemented in big integer Java class. Okay. Yeah. The reason is simple, overflow problem. Okay, yeah. So all integer operations in our prime factorization are Java big integer operations. So here I just give you some simple background about the big integer class. The reason is simple. The reason we do this way, we want to avoid overflow problem. Overflow problem. Yeah. Because if we do not use this special class, if we use long integer, we know it's 8, it only uses 8 bytes. Yeah. 8 bytes. It is very easy to get overflow quickly. Okay? Yeah. But in the real world, when we do prime factorization, usually it's on very big numbers. We should have no 8 byte restriction. We don't want this restriction. Okay? No such restriction. Okay, in the real world application. Okay, yeah. And the big integer, no digit number limit. Okay? You can use any number of digits in your integer. No limit. Okay. Why this number format allow us to handle any number of digits? So handle any number of digits for integers. But the reason is very simple. Simple reason. Yeah. Use string to represent integers. That simple idea. See, look at the idea is very simple. Use strings to represent integers. Each character corresponds to 1 digit. Okay, 1 character corresponds to 1 digit. Okay, think about in a string. Do you have limitation on number of characters? No, right? You never heard of. What is the limit on number of characters in a string representation? String expression. No limit, right? Yeah. So you can take this property and move to big integer class, no limit. Yeah. All right. So in this way, so you can see when we construct big integers, construct a big integer. Integer. All right, so here I show you a simple example. We use string, okay? All right. So example here, big integer. Then you have a reference. Let me call it big N equals, call constructor new. Okay, all right. Then the class name. Then the parameter we pass to the constructor, it's a string value, all right? For example, if it's 1, double quotes 1, semicolon, okay? Double quotes 1, double quotes 2. Okay. So if you put a valid string with digits as all the characters, should be valid. You should not use A, B, C, D. Use 1, 2, 3, 4, 0, 0 through 9. Then it's valid string. You can use to construct big integer. All right. So next, after that, then you need to do big integer operations. All right. Big integer operations. Straightforward, right? Yeah. Addition, but this time you need to call the methods. The methods in big integer class call its methods. Yeah. For example, here I just give you some simple example. Big and that reference addition dot add, okay? Then, all right, another big, all right? So big I, for example, all right? Yeah. So you add these two. You do not use plus, okay? You add these two big integer numbers. Yeah. Minus dot add, not add, subtract. Yeah. Minus big I, and so on. All right? Yeah. But you need to assign, okay? Yeah. That value you need to assign to some variable. Okay, all right. And multiply similarly. Divide. You can search the online big integer document, okay, the details. All right. And we also need to use a mod operation, integer mod operation to get a remainder. Okay, yeah. So use these big integer version, all these operations to rewrite the prime factorization method. Okay, yep. That's this feature. Rewrite prime factorization method. All right, yep. All right. So I hope you go through this step by yourselves, because I like you to have some big integer experience. Big integer experience. So in the real world applications, you may want to get around overflow problem. Sooner or later, you may need to get around the overflow problem. Then you can use big integer Java class. In Python, it has the built-in feature to get around that big flow, similar to the Java way. But that one in Python, that's the default. So you do not need to use anything special. You just do it. It automatically, it supports the feature you see in the big integer in Java. All right, yep. But in Java, you need to use big integer special Java class. Okay. All right, yeah. So that's the background before you try yourself. So I'll give you some simple background. Yeah. And after I fix the bugs in my example, my code, yeah, I can post it. Yeah. So if you couldn't get a prime factorization by yourselves, you can use my example. Okay, you can use my example. But I encourage you to try by yourself, because I like you have some big integer experience. Okay, yeah. All right, so let's move to the coding part. Yeah. Yeah, because we do not have much time, so I like to go a little faster. Yeah, so we just have a little more than half an hour. Yeah, but I need to show you something in my Java code. Yeah. All right. Yeah. So let me bring up my Eclipse. First, let me show you that big integer example. Yeah. Let me just use about 10 minutes to show you that big integer example. Then 20 minutes for the Java Bean feature. All right, so new. It is also dynamic web project. So big integer example 0. All right, because I have an old one, I'm working on it. So here I create a new version 0. Okay, all right. Finish. All right. Then I copy code. This code example I will post later. Yeah, big integer example. Okay, all right. Web part, only 2 JSP files. 2 JSP files. We copy. All right. Yeah. Then the Java code, we have one servlet. Only one Java servlet. So we copy the package for that Java servlet. All right. Then we can run it. After you see the result, then I show you some main features. All right. Yeah, you see the result. All right, so let me explain the result. The first line, I generate 100-digit big integer. I use random function. That function is included in my big integer example code. Yeah. So you have that. Yeah. Then I calculate the integer square root. So which integer is closest to its square root? Okay. Yeah. Because in our prime factorization, we need to use the square root number. Okay. All right. Then I want to check how close to the square root. So I take square of this number and do subtraction with the original number from top and the bottom. Okay, yeah, because you have two sides. Yeah, so you see two differences. Difference 1, difference 2. Okay, yeah. All right. So let me show you the code. Servlet, big integer servlet. All right, so this is my class. All right. First, look at this method. Generate big integer with number of digits n. Yeah. So you can see I use random functions, random methods, functions, methods. I generate this big integer number. So 100 digits, yeah, we just call this method, we generate 100-digit random big integer. Okay, yeah. All right. But in my prime factorization testing, this 100-digit integer factorization could be very slow. If that is the case, I may like to reduce the number of digits to some reasonable, because the response time, I do not want to see it's too long. So reduce the number of digits so that the response time is not too slow. Okay, yeah. So I will check that part myself. Then I will change the number of digits here. After I did experiments, I will change the number of digits here. Yeah. All right. So that's one. After that, you can see, yeah, I use that binary search algorithm to calculate the square root of big integer. Yeah. So if you are familiar with the binary search, then you can get the idea. Yeah. So here, you can see I use a while loop to get my estimate of the square root closer and closer to the closest number to the square root. we know the square root usually it's not an integer, right? So we can only use another integer to approximate the square root. But when we approximate, we have two directions to approximate, from upper direction and from lower direction, right? Yeah. From upper direction, then there is a difference. That's the difference 1. From lower direction, there is another difference. So I call it difference 2. So in the display page, you see difference 1, difference 2. That is difference 1. We calculate difference from upper approximation. Difference 2, you see the approximation difference from the lower direction. Yeah. All right. So then here I use many basic operations. Yeah. So you try to understand. So then we store in request.set attribute, we store the numbers we want to display in the result.jsp, result.jsp. Okay, all right. Yeah. So then you can see the result in the display page, result. Okay, all right. Result display page. Yeah. So we retrieve those numbers, then we display. Use JSP expressions. But actually, you can see we can use EL. If we use EL, we can do in a much simple way. Okay, yeah. Here, let me show you. Let me change 1 to EL. Okay, all right. This diff2, difference 2, I like to use EL to display it. All right. The attribute name diff2, yeah. So let's just put diff2 here. Okay, yeah. So then remove the JSP expressions and save. All right. Similarly, diff1, yeah, because after we use it, we do not need this line. We do not need that line. Okay. Similarly, for diff1, if we use EL to display directly, we can remove. All right. All right, so now let's go back to see the result page. Let's refresh. Yeah, so you see, you know, we can still, because when you refresh, every time we call the servlet again, we should get a different random number every time. Refresh, different random number. So all the numbers should be different. And we can use all EL expressions. If you like, you can use all EL expressions. Okay, yeah. All right. So that is the big integer part. Then another thing I like to do, that Java Bean part. So let me, because that part actually also pretty easy, pretty straightforward. Yeah. So I like to show you how to do it here. Let me use my sample B and modify the code here. All right. Resource, package, okay? Yeah. Package, yeah. So I have these classes, all right. So if I put a Java Bean here, yeah, let me create a Java Bean. New Java class to create Java bean, you just select the class. Okay, all right. So then give a name of your Java bean class. Okay, all right. Here, let me just call city rate bean. Okay, city rate bean. Yeah, Java class. Yeah. Then the data structure, we like to put property private city list of string object. Then property name cities. List, we need to import this interface. Okay, all right. And double. Rates. Okay, all right, yeah. Then we need to generate setters and getters for this Java bean. Yeah. Here we use the automatic way to generate. Right click anywhere in this code window. Yeah. Go to source. Source, you see, generate getters and setters. Select all, these two instance variables. Select all, click generate. Then these setters, getters generated automatically. Okay, all right. So that's our Java bean. Okay. Then in our big integer servlet. Oh yeah, not this one. Yeah, not big integer servlet. You know, in our start servlet. This time we need to use that object. Okay, we need to use city rate bean class. Okay, yeah. First, we call the constructor. Yeah, because it's in the same package. So we just use it directly. All right. Then, after the for loop, we put a data there. Not this one. City rate. City rate. Dot set. Set cities. Look at that. City list. Okay. Yeah. Dot set rate. Rates. Rate list. Okay. All right. Yeah. So we store these two list objects in this Java bean. Okay. The last thing, we need to store it in the request scope. Okay, all right. So city, let's call it city rate. City rate. Here also city rate. All right. Okay. Yeah. All right. So the servlet preparation part, that's the modification. Right. Next, we move to the display page using EL to display result, not result, input, right? Input here. Now look at that, city, what should be city radar, right? Yeah, because the attribute name called city rate dot cities. How about that? How about that? Similarly, the rates part, that city rate, that's the attribute name, our Java Bean attribute name. Dot rates. Yeah, it's property. Get cities, let's check. Get cities, yeah, get rates. Yeah. So we call getters. Get cities, get rates. Okay. Yeah, see? That's how we get the data from Java Bean. Okay. All right, so now let me run it. Yeah. So let me stop the server and run this one. Small modification, you can see. Yeah, see, same thing as before, right? Same thing as before, but this time we use the Java Bean to carry the data. So that's our project requirement, calculate. Yeah. The same as our sample B, but I like you to do Java Bean way. Okay? Get some experience using Java Beans for data storage and a data display. Okay, yeah. So that's sample C, sample ABC. So this project, you can see ABC plus prime factorization. Yeah. But the last thing I didn't show, so you need to do the last thing, display result. You invoice, right? Invoice part. Invoice part, I think I do not need to show you. So you can do the invoice part by yourselves. Calculate the service charge, tax rate, and show that invoice as the final result, final charge. Okay, all right. Yeah. Any question about this project? I think with the help in this way, I hope everyone won't miss it. Everyone, you can do it. You try to understand, you can use my code, but you need to put things together. You need to do some work, put things together. Okay, yeah. All right. Then I have a few minutes, I can talk about our project number 2. Project number 2. Here, let me go back to my PowerPoint slides. Yeah. Use some space here. I talk about project number 2. Because our project 1 will do quickly, although I set 3 lines, right, for extra credit. Yeah. But I need to post project number 2 quickly. Yeah. So here, I have an idea. Yeah. I like to do in this way. Yeah. All right, so let me use the space here for project number 2. Yeah. I like to do something meaningful, useful, but at the same time, it's doable. Okay. Yeah. Yeah. Something useful, meaningful, right? But at the same time, doable. If it's too hard, because we do not have much time left in the remaining of the semester, okay? So I need to control. So not too hard for you. It's doable. Yeah. So then my ideas. Yeah. The problem. Yeah. The problem is online shopping. Online shopping web app. Yeah. But I give you one example. Yeah. Otherwise, it's too hard, right? If I ask you to write this one from scratch, that's too hard. Yeah. But I give you an example. My example already. Yeah. So it is a bookstore example. Bookstore example. Yeah. Actually, it uses JSTL. Uses JSTL to, do online shopping. Yeah. The example is relatively complicated. Yeah. But not too complicated. I will explain the code. Yeah. I have a tutorial, but in class, I also explain the relatively hard part to make sure you understand completely. Yeah. Actually, the most important part, you need to implement that shopping cart. Because we know online shopping, you need a shopping cart, implement the shopping cart feature. Okay. Yeah. How to create and maintain shopping cart. Think about that. Okay. Yeah. After you study and understand my example, then for each of you, I ask you to write your own online shopping store. Yeah. You just imagine you run your own business. So each student, you run your own business, online shopping business. You can imagine, you can make a story. You want to sell some interesting product, okay? A set of products, okay? So display, yeah. And you design your products, hopefully not too complicated. Yeah. In your design, you make it, relatively simple, not too complicated. Yeah. In this way, you modify existing online shopping example to create your own online shopping web application. So I expect each student working on different examples. So when I do the grading, I want to see different students selling different products, different types of products. Okay. Yeah. But the basic feature pretty much the same, right? So you list all your products, then you allow the, buyers, customers, check, select some of the products, put in the store in the shopping cart. Okay. Then we know the shopping cart, the users can edit the shopping cart, right? Edit, remove from the shopping cart, can change, can add some more products, remove from the shopping cart, and so on, right? And at the end, order button, right? Order button, then you calculate total amount of money to pay. That is the plan, our project number 2. We need to do this. Okay. Yeah. But with the existing code, you need to understand, you can modify. The reason is because in the real world, usually when we work on a new project, many features we borrow from existing code, right? That's very common. Most programmers do it this way. So first, they try to find the similar code examples. Then they modify the code examples to make for the new features in your project. Here we do the same thing. Yeah. But I give you an example that's pretty close. That's what we want to do. You just sell different products. Okay? You try to find some products you like to sell. Online way. All right. That's the plan for our project number 2. Yeah. And later I will show the demo of this example, and I post this example. And in class, explain the main features, mainly shopping cart. I explain the features around that shopping cart. So make sure you understand well. Then you can modify the code. With good understanding, you can modify the code, right? Yeah. All right, so that's it. So